SQA National 5 Maths 2019 Paper 2 Question 1. A charity distributed 80,000 emergency packages during 2018. The number is expected to increase by 15% each year. How many packages is it expected to distribute in 2021? So again, there's our amount, there's our percentage, and then the time we can work out is the difference between the years. So looking at the percent first, we start with 100%, we add 15% because it's going up, 115%, change that to a decimal, which is divided by 100, 1.15 is our key multiplier. So now we take our 80,000 times by 1.15 to the power of, well, the number of years, 18, 19, 20, 21, 3 years. Get a calculator, 80,123 times 1.15 to the power of 3, 121,670. 121,670. And we're done there. SQA National 5 Maths 2019 Paper 2 Question 2. Find the magnitude of vector P. So magnitude is just like Pythagoras. I just square each number and square root them. 6 squared plus 27 squared plus minus 18 squared. Square root 6 squared plus 27 squared plus minus 18 squared is 33, and we're done there. National 5 Maths 2019 Paper 2 Question 13. So for this one, again, we've got our angle, so we'll call that our C, and then the other two sides could be our A and our B, and that would be our A and that would be our B. Calculate the area of triangle PQR. So the area is a half AB sine C. So for a mark, 0.5 times 70 times 45 times the sine of 129. You get a mark for the substitution, and then a mark for the final answer. You just get your calculator out and do 0.5 times 70 times 45 times sine 129 in the calculator, and you will get 1224.004. So that would be fine to leave it as 1224 square centimetres. SQA National 5 Maths 2019 Paper 2 Question 4, Scientific Notation or Standard Form. A sesame seed weighs 3.6 times 10 to the minus 6. The weight of a poppy seed is 8% the weight of a sesame seed. Calculate the weight of a poppy seed in kilograms. Give your answer in scientific notation. So in other words, I need to work out 8% of 3.6 times 10 to the minus 6. So in a calculator, I can do 8 times that and then divide by 100, or just do 0.08, because that's 8%, times 3.6 times 10 to the minus 6. Now, when you do that in your calculator, you might get an answer of 0.000000288. Or if you're lucky, your calculator will give you it in scientific notation. But let's assume it didn't, and it didn't give us this answer. We need to change that to scientific notation. So our first number is 2, so it's 2.88 times 10 to the power of minus, because it's a number which less than 1. And to get that, we imagine our points here. So 1, 2, 3, 4, 5, 6, 7. Minus 7. And it's kilograms for our units. And we're done there. National 5 Maths 2019 Paper 2 Question 5. The diagram shows a cone with diameter 6 and 8. The x and y axis are tangents to the base. A is the point of contact with the base on the x-axis, and B is directly above the centre. Find A and B. So let's see where A is. We need to go from here to here. Well, that length is the diameter 6, so that length is 3. I can just take a note of that here. That goes along 3. I go along 3. I don't go in and I don't go up. So it's 3, 0, 0. So straight away, A equals 3, 0, 0. Let's find B. B, I need to go along 3, in 3, because again, diameter 6. And then I need to climb up the whole height. Now the height is 8. So it's 3, 3, 8. And I'm done there. SQA National 5 Maths 2019 Paper 2 Question 6. Solve the equation 3x squared plus 9x minus 2 equals 0 to 1 decimal place. Right, it's a quadratic. It's asked me to 1 decimal place, so it's a quadratic formula. So I go to the front of the page and write down the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is the number in front of x squared, which is 3. B is the number in front of x, which is 9. And c is minus 2. So I need to sub this in carefully. That's minus 9 plus or minus the square root of 9 squared minus 4 times 3 times minus 2 all over 2 times a, 2 times 3. So you get a mark for substitution usually, then a mark for working out the bit under the square root sign, which is called a discriminant. So I'll work it out next. Minus 9 plus or minus the square root of, well, 9 squared is 81. Well, let's use a calculator, shall we? 9 squared minus, I'll open a bracket, 4 times 3 times minus 2. That's 105. All over 2 times 3, which is 6. So now we've got two answers. X equals minus 9 plus root 105 over 6, or x equals minus 9 minus root 105 over 6. So let's do them both separately with a calculator. Brackets for the top, minus 9 plus root 105. Close the bracket, divide it by 6. That gives me 0.2078. I'll just put dot, dot, dot. And then the other one, brackets, minus 9 minus root 105 over 6 is minus 3.207 with a bunch of other numbers. And we'll round that to 1 decimal place, so then that gives me 0.2 or minus 3.2. Always show your unrounded answers first before you round. And finally, look at an example of using the cosine law to find an angle. SQA National 5 Maths 2019 Paper 2 Question 7 had this. It had a triangle with all 3 sides shown. Find the smallest angle in this triangle. Now, you may be wondering, how do I know what the smallest angle is? Well, it's pretty obvious just from the way it's drawn as well, but it is this one. So we'll use this as our smallest angle. So we'll relabel that A, and that'll be side A. And then the other 2 sides can be B, side B, and C, side C. Now, calculating the angle, I know to use the cosine rule because I'm given all 3 sides. From the start of the exam paper, cos A equals b squared plus c squared minus a squared all over 2bc. You don't need to remember that, you just need to be able to use it. So we'll just substitute all our numbers in, being very careful. So b squared is 8.5 plus 7.2 minus 6.3 squared. You're always taking away the 1 which is opposite the angle. All over 2 times 8.5 times 7.2. That's cos A. If you can get that far, that's a mark. So then we can do the inverse cos of our answer. Now, let's just tidy this up a little bit. If we work out our top, we get 84.4. If we work out our bottom, we get 122.4. Now, at this stage, you can either just divide them to get 0.689 or do the inverse cos of that fraction. It doesn't really matter what you do. And that means that A equals the inverse cos of 84.4 over 122.4. In a calculator, you get A is 46.4 degrees for your final answer. A volume question, SQA National 5 Maths 2019 Paper 2 Question 8 had this one. A traffic bollard is in the shape of a cylinder with a hemisphere on top. So it's an adding one, cylinder plus hemisphere. The bollard has a diameter of 24 and a height of 70. Calculate the volume of the bollard. So I'm going to have to do the volume of a cylinder and the volume of a hemisphere. Now, to do the volume of a hemisphere, I need its radius. I know its diameter is 24, so the radius must be 12.
So I can say that this radius here, just marking my diagram, is 12. There's another piece of information I need. I need the height of my cylinder. So I need to do 70 minus this 12, because it goes all the way up. 70, take away 12. That gives me 58. Need to do that work to be able to do my sums. The volume of our hemisphere. Just remember, hemisphere is half a sphere. So it's a half times 4/3 times pi times 12 cubed. Put all that into a calculator and you get 3619.1 centimeters cubed. Now we do the volume of our cylinder. Cylinder's area base times the height, so it's pi r squared times height. If you're not going to remember a cylinder, it's the same as a cone without a third on it. A cone's a third of a cylinder. So it's pi times the radius of 12 squared times the height that we worked out earlier is 58. We do all our sums in a calculator and we get 26238.5. Centimeters cubed. So now we just need to add our volumes together. So the volume in total equals 3919.1 plus 26238.5, which gives us a grand total of 29857 point and a bunch of stuff. Who cares? 0.6 and a bunch of other stuff, because we're going to round it now to 3 significant figures. So 3 significant figures, 1, 2, 3. We need to round here, so it's 29900. 29900 centimeters cubed. Make sure you write down your units.
Identities, National 5 Maths 2019, Paper 2, Question 9. Georgia had a roof repaired. She's charged an extra 2.5% for late payment. She had to pay a total of $977.85. How much would she have saved if she had paid on time? So we need to realise that 102.5%, 100 plus 2.5% equals $977.85. So we need to, usually we go down to 1% and back up to 100, because usually we want to know how much it cost before, but this time we need to read the question. How much would she have saved? We just need to work out what 2.5% represents. So to work out 1%, we get our calculator out and do 977.85 divided by 102.5, and that gives us an answer of £9.54. And therefore, 2.5% is what she paid, so I do 9.54 times my 2.5, and that gives me a final answer of £23.85. So she would have saved £23.85. Next grade National 5 Maths 2019, Paper 2, Question 10. Express x squared plus 10x minus 15 in the form x plus p squared plus q. So this is called completing the square. If you ever see it in this form, that's what it is. And there's a simple way to do this. You half the middle term. So the middle term is 10. So I write x plus 5 squared. You then always immediately take away, and then it's 5, so it's 5 squared. But then you've still got minus 15 on the end from the question. So I've got my x plus 5 squared. I'm taking away 25, because that's 5 squared. I'm taking away 15. So you've got x plus 5 all squared. Minus 25 minus 15 is minus 40. Use a calculator if you need to. And we're done there.
2019, Paper 2, Question 11. Converse of Pythagoras. The diagram shows a jet ski race. The course is marked out by markers A, B, and C. It says B is 600 metres from A, C is 650 metres from A, and C is due north of B. Determine whether B is due east of A. Well, if it is, it will be a right angle. Now, you cannot use Pythagoras to get this missing side, because you're going to try and prove it's a right angle. So we'll start off with the fact that the whole course is 1500. 600 plus 650 is 1250. We take that away from 1500 to get 250 metres, and we just mark that on. We know that's definitely 250. Keeping it all separate, we've got a left-hand side and a right-hand side. our left-hand side is 600 squared plus 250 squared, and our right-hand side is 650 squared. Do not write they're equal, that's why I draw a little table and keep them separate. We then work out both sides separately. So the first sums gives us 422,500, and 650 squared, if you work that out in a calculator, also gives you 422,500. So then you can say, since 600 squared plus 250 squared equals 650 squared, then angle is right angled is a right angle. So we could then write what we're trying to say. A is east of B. B is east of A, sorry. And we're done.
A Square National 5 Maths 2019 Paper 2 Question 13 on sector area and similarity. It says in the diagram that sector ABC is a sector of a circle with a centre C, and DEF is a sector of a circle with a centre F. The sectors are mathematically similar. It says the area of the larger sector is 2750. Find the area of the small sector. So we're using area scale factor. So we need to find the linear scale factor first and then find the area scale factor. So we have to do the smaller one. So we start with the smaller side, 30, over the big side, 50. So our linear scale factor is 30 over 50, or you can simplify that to 3/5 if you want, which means our area scale factor, remember, we'll just square that scale factor, 3/5 squared. Calculator paper, so you can just do 3 3s is 9, 5 5s is 25 in the calculator. So now to get the area of the smaller sector, we just take our scale factor and times by the area of the big sector, which is 2750. Now this is a calculator paper, so let's just do that. 9 divided by 25 times 2750 is 990. 990 centimetres squared. And we're done there. He says calculate the size of angle ACB. So we're in the big sector, and we know that if we've got an angle, then angle over 360 times pi r squared, because we're doing sector area, equals the area. Well, the area I'm given is 2750 for the big sector. So we're just working backwards from there. So to get your theta, I find the easiest way to work backwards is start with your answer, which is 2750. And as you go back, every time something's on the bottom, that now turns up on the top. So times 360. And anything that was originally on the top for times in, we just divide by it. So we've times by pi r squared. So we divide by pi r squared. And R, remember, for the big sector is 50. Pi times 50 squared. And then we just get a calculator and work all that out. Now you can do it in one go in the calculator. You just bracket 2750 times 360 divided by bracket pi times 50 squared. Close your bracket and you get 126.05 or 126.1 degrees. And we're done there.
Square National 5 Maths 2019 Paper 2 Question 13 on gradient. Find the expression for the gradient of a line joining A is 69 to the point B is 4p and 4p squared. Give your answer in its simplest form. Don't worry if it was algebra in this question. You can still just do it using the gradient formula and you'll just have an algebraic answer. So A is x1 and y1, and then we've got x2 and y2. So M is y2 minus y1 over x2 minus x1, which equals 4p squared minus 9 on the top, and x2 is 4p minus 6 on the bottom. You'll get a mark just for substituting it in, but then we need to tidy that up so it's now become algebraic fractions. So we can factorise the top and maybe the bottom and then work on it there. So 4p squared minus 9 is a difference of two squares. So that is double brackets, square root of 4p squared is 2p, the square root of 9 is 3. So it's 2p and 3 in both brackets, plus in one, minus in the other, all over. And 4p minus 6 has a common factor. The common factor would be 2, so I can take 2 out as a common factor. 2 times 2 is 4, so it's 2p. 2 times 3 is 6, so it's minus 3. you get a mark for factorising the top. And then we can go ahead and cancel down to get our final answer. So 2p minus 3 and 2p minus 3 can be cancelled to leave us with 2p plus 3 all over 2 for our final answer. Grade National 5 Maths 2019, Paper 2, Question 14. Solve this equation, 5 cos x plus 2 equals 1. So I'll take away 2 for both sides. I get 5 cos x equals minus 1. So cos x equals minus 1/5. So I'll do the inverse cos of 1/5. And you would get 78.5 degrees to one decimal place. So that means that x equals, using a cast diagram, since cos was negative, I'm picking s and t, because a and c would be when it's positive. So I'll do 180 minus 78.5. And I do 180 plus 78.5. That gives me my two answers. So x equals 101.5 or 285.5. Simplifying algebraic fractions, Grade National 5 Maths 2019, Paper 2, Question 15. Express 4 over x minus 2, take away 3 over x plus 5 as a single fraction in its simplest form. So this works exactly the same way as fractions when you're adding them before or taking away. You need a common denominator. Now the easiest way to get a common denominator, especially with algebraic fractions, is times the bottoms together. So I can put brackets around these. My common denominator is going to be this. So as a single fraction, I'm making it nice and long, I've got x minus 2 times x plus 5 on the bottom. Now to get your tops, well, you can think of it as this fraction's been times by this, so I need 4 times x plus 5, and this fraction's been times by x minus 2, so I need minus 3 times x minus 2. Or a quick and easy way to think of this, especially last minute, is I'm crossing over like this. So it's 4 bracket x plus 5, make sure you've got your brackets around there, minus, because it says minus, 3x minus 2. And there's your fraction. So now you need to simplify that, so we're going to expand the top. So expanding the top, we get 4x plus 20, 4 times 5, minus 3x, and what's your minus times a minus? That gives you plus 6. And we've still got our x minus 2, x plus 5. There's no need to expand the bottom. So that gives you 4x minus 3x is 1x, 20 plus 6 is 26, over x minus 2, x plus 5. And just double check, once you've done this, can you factorise that? No, you can't, so you can't simplify any further. There's nothing else you can do. So we're done there. Okay, laws of indices, Grade National 5 Maths 2019, Paper 2, Question 16. Simplify a to the 4 times 3a all over the square root of a. So let's just write that out. A to the 4 times 3a, all divided by the square root of a. Well, let's deal with the top first then. 3 is just times by 1, which is 3. And then the powers, I can put a little 1 on this and add the powers. Law 1. 4 plus 1 is 5. So I get a to the 5, and that's over the square root of a. Now, to divide by the square root of a, I'm doing indices, so I need everything to be indices. So that's going to be 3a to the 5 all over a to the half. The square root of a is a to the half. And now I'm dividing indices, so I can take away the powers. So that is 3 to the a, and it's going to be 5 minus a half is what I need to do. Now 5 minus a half, I want it all in fractions. So I will change that to 3a. And you might know this already, but 5 is 10 halves minus 1 half to be very clear. So that gives you 3a to the 9 halves. Now you could leave your answer like that because it says just simplify. It doesn't say put it back in a root. But if you were to put it back into a root, it would be 3 times the square root of a to the power of 9 would be your final answer. Grade National 5 Maths 2019, Paper 2, Question 17. Expand and simplify sin x plus cos x all squared. So it's a double bracket question as well. So I've got sin x plus cos x times sin x plus cos x. And expand that any way you want using a grid or foil. I'm just going to use foil for the sake of quickness. So first, Sine x times sine x is sine squared x. Outside sine x cos x, so it's sine x cos x. Inside is cos x sine x, but I'll just write sine x cos x to keep the order the same. And cos x times cos x is cos squared x. So that's your first mark there for getting your expansion, and then for tidying it up. So we need to tidy this up somehow. So we've got sine x plus sine x cos x plus sine x cos x. That's two lots of sine x cos x. But we've also got sine squared plus cos squared. If you remember our trig identity, sine squared plus cos squared equals 1. So that all simplifies to 1 plus 2 lots of sine x cos x for our final answer. National 5 Maths 2019 paper 2 question 18 had this question. It's a cartoon snowman and it's got a lot of information about the head is a small circle with centre S and the diameter of that from here to here or here to here is 15. The large circle has got a centre of T and it also lies on the circumference of this one. And A and B lie in the circumference of both circles. Calculate the height of the snowman. Looks quite difficult. But if we notice, we know this line here is 15, so we're really just being asked to calculate the radius of the big circle. Now we can calculate it anywhere. So if I go inside this bit from here to the outside, that's a radius of the big circle too. I'll draw that in. And we already know of some facts. We know that'll make a right angle. But we know that the diameter of the small circle is 15, so that is 7.5, but so is this. So taking that outside of the circle, just to be clear, we have got 7.5 here and 7.5 here with a little x here. So x squared is 7.5 squared plus 7.5 squared. So that means that x equals the square root of 7.5 squared plus 7.5 squared, which we can calculate and then square root or just use brackets to get about 10.6. So that means now that our height is just, well, let's just double check. It's going to be the diameter to T, which is 15, plus the radius of the big circle, which we've just worked out is 10.6. That gives you 25.6 centimetres. National 5 Maths 2019 paper 2 question 19 had this long question. So it says Katie and Mona are looking up at a hot air balloon. In the diagram below, K, M and B represent the positions of Katie, Mona and the balloon. So that'd be Katie, that'd be Mona, that'd be balloon. The angle of elevation of the balloon from Katie is 52, there it's shown there. The angle of elevation of the balloon from Mona is 34, there it's shown there. And the distance between Katie and Mona are 350. And it says, calculate the height of the hot air balloon above the ground. It's quite a hard question. It's worth 5 marks. Notice, it's not asking me to calculate any of these diagonals. It wants me the direct height. So I can draw in a direct height here to show this, just by drawing a straight line down. And that's the side it wants me to calculate. Do not be tempted to think that cuts this line in half. It does not. So I'm going to need to get one of the other sides in order to use the sine rule or to use SOHCAHTOA to get the height. So that's exactly what I'm going to do. I'm going to start off by using the whole triangle to get one of the sides. You can pick any one you want, okay? I'm going to calculate this one, but you could go the other way and calculate this one. So let me draw a little diagram for us or take some notes on this one. If I draw that without all the information, it's sometimes easy to do this. You've got 350 down here. I've got 34 degrees here, 52 degrees here, and I want to calculate this side here. I'll call that A. So I'll call that bit A. So I've got this pair, and I'll need another pair, but I've not got this one. So the first thing I'm going to have to do is get this angle at the top because I need it to go with this one. So adding these two numbers together and taking away from 180. So 52 plus 34, that gives us 86. 180 minus 86 is 94, so I can note that that is 94 degrees and start my work. Got A over sine 34 equals 350 over sine 94. And if you're going this route, you'll get a mark for that. We now need to rearrange that. So a sine 94 equals 350 sine 34. So a must equal 350 times the sine of 34 over the sine of 94. So getting a calculator and working that out, you get a is 196.195 or 196.2 would be fine, or even just 196. So far I've got 3 marks, substitution, rearranging and getting an answer. But now I need to get the height, okay? So redrawing my triangle to side with all the information I've got now. I want this height here. I know that this bottom whole thing is 350. I've just calculated that this one is 196.2. And I know some angles. I know this is 52 degrees. This is 34 degrees. I'm not going to bother putting this on because it doesn't cut it in half. It adds up to 94, but it doesn't cut it in half. You can calculate either this angle or this angle using right angle triangles here. But there's lots of ways now to work out this height. The easiest way is to use the sine rule again. So we'll go ahead and do that. We have got, if I use a different colour, I'm going to use this one, goes with this one. And we're going to use this one, this is an angle B, goes with this one here. So we can just simply write A over sine 52 equals 196.2 over the sine of 90, because that's 90 degrees. Rearranging that, that implies that A times the sine of 90 equals 196.2 times the sine of 52. So A equals 196.2 times the sine of 52 divided by the sine of 90, which is 1, by the way. Just a note on this question. Once you get to this point, that is a right angle triangle. You could have just used SOHCAHTOA to find A. I basically didn't, but I've just not bothered to do it for this question because SOHCAHTOA is a national 4 skill, but you might have forgotten. You don't need it at all in national 5. You can just keep using the sine rule, just use the sine rule twice and realise that this angle is 90 and you'll be good.